Sleep? Oh, good. Okay, I got a couple of responses there. Good. Thank you. Okay, so let me go back to the homework. So, okay, question 8. Download the vital statistics, summarize leading causes of deaths, heart disease, poisoning, influenza, and then probability of male death was due to probability of female death. In other words, those are conditional probabilities. Given that somebody's male, what's the probability they die from pneumonia and so on and so forth. So let's go to take our look at the. Now, first of all, when you download it, this is what the report looks like. And they have a report like this for every year, going back many, many years. You can take a look at the chart. In the beginning, it's a chart of mortality in the city of New York. And you can see, if you look at this closely, it's very interesting. You can see when various outbreaks of diseases have taken place. Here is the 1918 influenza outbreak, and you can see a big spike in the number of deaths in New York City. Thing that was remarkable about that, particularly remarkable about that, is many of the people who died were not older people, which would not be that surprising, but were younger people. The nature of the particular flu that they had that year, what something that made it uh, uh, concerning. Okay, and you can also see many waterborne diseases, cholera, is a diphtheria outbreak, smallpox, cholera, big killers in the 19th century, because of poor sanitation. And then as sanitation improved, and as we get into the 20th century, sanitation has improved quite a bit. And as we go forward through the 20th century, we have antibiotics and all sorts of other supportive treatments and so on and so forth. So the death rate, the mortality rate goes down quite a bit. So it's really interesting. So let me go back to this. Oops. But if you go through this, this has all sorts of interesting statistics about the city of New York. Now, the particular chart that I led you to was this first chart, which is just a summary of the leading causes of death by age in New York City in the year 2013. That's the most recent year that they have all this data accumulated for. You can go back and look at these for. I think they have online. They have like dozens of these online, so you go back a number of years. Okay, now it is broken down by age and gender. However, at the top here, the first section here summarizes the leading causes of death by all ages together, and that's the part that I singled out so that you guys could work with it. I also extracted that for you, save you a little bit of trouble. So if I can't find it here, there you go. I just pulled out those first numbers. I just took this column and I took the number of deaths for males, the number of deaths for females, and I put them together into this. So this is really just drawn from that table. Okay, I probably should have made you do that work for yourself, but I was feeling charitable. Okay, so at any rate, let's take a look at what I asked you for in the problem. Okay, what I asked you for in the problem, if I can find it again. Okay, first thing I asked you for is if a person died in New York City in 2013, what's the probability cause of death was heart disease? Okay, so that should be pretty straightforward. I'm looking at all causes, all genders, all people. Heart disease killed 16,000 people, 17,000 people, out of a total number of 53,000 deaths. Now, notice this is not a mortality rate. In other words, real mortality rate, I would be looking at the number of people over the population, 8 million in New York City, to determine a mortality rate due to heart disease for the population in New York City. This is the proportion of people or the probability that if a death occurred, that it was due to heart disease. So that would be 17,000 over 53,000, right? So you guys can figure that out on your own. The next question was, as we go forward, it gets a little bit more interesting. Next question was poisoning. What's the probability of that the cause of death was poisoning, all types? Well, I got a couple of questions on this already. Let me move that out of the way. Got a couple of questions on this already. Notice they separate poisoning into two categories: accidental poisoning, except by psychoactive substances, and use of or poisoning by psychoactive substances. I was hoping that you would combine both of those, any form of poisoning, due to psychoactive substances or not. Um, uh, uh, so this would be accidental overdoses. It might be children getting hold of lethal doses of some psychoactive substance that they found or something like that. But in any case, both of these are a form of poisoning. So I was looking for the sum of these two over the total number of deaths. Okay, next I think was the probability of dying from pneumonia or influenza if you were male. Well, that's a conditional probability. Now, I'm not looking at the total of 52,000. I'm only looking at the males. And how many males died from influenza? 1,200 out of 26,000. Next was how many females died from influenza? What's the proportion of females died from influenza? And that was 1,200 out of 27,000, and so on. I had to correct that. I had an error in a decimal place, I think. But I did correct it, so when you submit your homework, it should grade properly. And this time around, I let the answers and the results appear when you submit the homework. You're welcome to go back and give it another shot. Retry the homework, but it's going to make you do the whole thing again. It will not preserve your previous answers. I'll have to look into if there's a way to have Blackboard do that for you, but I'm not sure that there is. Okay, so that's really basically that's not too challenging, I don't think. And let's see I think that might have been it, right? Yeah, that was it for that homework. Okay, so hopefully if you can get through that kind of stuff, you have a pretty good start on what likely in these groups might be on the exam. Okay, so you got to be a little bit, there might be some multiple choice questions or short answer questions. They might ask you, for instance, what would you expect to happen in positive predictive value if the prevalence of a disease goes down, right? Or they might ask you something about uh, 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 conditional probabilities that might be word problems and so on and so forth. So just make sure you run through the slides and you do the readings and stuff like that. You should be in pretty good shape. I already have a few people submitted homework. Says most of them have done okay. I think the poisoning one I think might have been a little confusing to a couple of people, so I might increase the range there. So basically, it's impossible to get wrong. But that's what I had. Now you know at least what I had intended there. So I'm going to go backwards to assignment 1 now, since we've gotten through this. We managed to get through this. Okay, let me go back again. I can't go back here. Let's see. I'm going to have to go back here, it looks like. Okay, here we go. Assignments. And assignment 1. Let's take a look at what we have here. Okay, let's take a look at, now you guys did pretty well on this, I thought, right? Where assignment 1, we covered the data types, we covered a lot of stuff about descriptive statistics. We got into that, histograms, graphical display of data, box plots, and so on and so forth. So all of that's going to, I'm sure, come up on the exam. The first couple of questions had to do with data types, and basically we're looking at 3 primary data types: nominal or categorical. You could describe it either way. Numerical, a number, a value or a number on a scale. Sometimes people break that up into 2 groups, a scalar, like a number on a scale, or numerical, or sometimes they call it interval numerical. An interval basically implies integers, like number of siblings, usually a small number, like three siblings, or 8 siblings, or 2 siblings, and so on and so forth. With larger numbers, typically, I'm not sure that you're going to come across too many places where you handle that data other than numerically anyway, whether it's interval data or scalar data, numerical data. And in fact, SPSS only gives you those three choices: a scalar, that's what it calls numerical, nominal, and the third one, which I haven't mentioned yet, which was ordinal. Now, ordinal gets a little bit. Now, I just want to, where interval is concerned, many times people will say, "Oh, blood pressure isn't that interval because it's only whole numbers." I go to the doctor, my blood pressure is 105 over 68. That's your blood pressure. My blood pressure is higher than that. You're younger than I am. But the blood pressure is 120 over 80 or something like that. That's not a bad blood pressure, right? So 120 over 80, right? And say to yourself, well, that sounds like an interval, like an integer. Well, in fact, what they're doing is they're rounding a number. Your blood pressure could be that's the number of millimeters of mercury, weight of the number of millimeters of mercury. It could really be 120.01374. It's indeterminate. They just rounded it to that number. So it is in fact a scale or scalar number, right? Not an interval. So don't take that idea of integer too literally, because a lot of times people describe something like height, 63 inches, when in fact you could be an infinite number of possibilities between 62 and 63. So, okay, the third type of variable is an ordinal variable. Ordinal variable appears like a number. It has a value like a number, or it could be a word that sounds like it has some value you could assign to it, because it's more or less than some other description that you could use. For instance, if you're grading a course, you might say poor, fair, good, very good, or excellent. Okay, so those have an order. Poor is lower than fair, and good is greater than fair. Very good is greater than good, and excellent. We can understand that order. The problem is that we can't really quantify what the difference between those are. In other words, is the difference between good and very good the same as the difference between very good and excellent? A lot of times we can't quantify that. So rather than looking at it as a number, in other words, translating that strictly into a number, we look at it as just having a certain order, and that we define that as ordinal. Okay, pain scale is a typical version of that. You ask a patient what your pain level is on a scale of 0 to 10. There are two problems there. You know that if the patient says one day that their pain level is 6 and the next day that the pain level is 8, or before taking medication their pain level was 9 and now they tell you their pain level is 3, you know that they're experiencing, they're describing to you that they're experiencing a lower level of pain. But you don't know whether one person's 3 is someone else's 6, or if that person's 6 is someone else's 9, right? You can't really quantify that. You also can't quantify whether or not when a person tells you that their pain level went down from 8 to 6, whether that's the same, if that has the same value as going from 4 to 2, right? So all you can tell is the order, right, essentially. So that's why we call that ordinal, and we have special ways of analyzing that data. And basically, the reason why we're interested in defining these things is because it's going to impact the way that we do an analysis with this data. Okay, so let's take a look. I'll leave that to you. I think you get feedback when you answer those on which ones are right and which ones are wrong. In fact, I'm going to go back and make sure that the feedback is turned on so you can tell which one of those you got right, which one you got wrong when you go back and look back at it. Okay, question number 5. Referring to the image chart. Yeah, this was a little confusing to some people also. I don't have that handy. Maybe I do have it handy. Let me see if I can't find that. Okay, homework 1. Maybe there's a folder there, homework 1. Nope. Yeah, I don't see it. Well, actually, you know what I can do? I can actually open this up and I can actually download it. Let me open a new window. Okay, I'll go into assignments. Okay, and what we were looking at there, we were looking at charts. This guy right here. Okay, let's take a look at these. What we're contrasting is the charts in A, the charts in B, and the charts in C. And just after a while, you kind of train your eye for this kind of stuff. But if I look at this, if I see the difference between, well, the charts in B all seem to be heavily weighted on one side, and then there's values that way out to the outside on the left side, on the right side. Those are skewed, right? And it happens, they're skewed. In other words, the values, you have a few values that change things dramatically because they're further away from all the other values. They're skewed to the right or positively. This is skewed to the right or positively because there's a few values that change where the mean is because they're so far away from all the other values. Okay, so those are skewed to the right. I can look at these over here and I can notice, boy, every one of them seems to have two peaks, seem to be bimodal or multimodal, right? The mode is the highest values. You have two groups, two areas where you have an unusually high number in one of these bars. So those values are high for that number, okay, the frequency or number of people in that group. So these are multimodal or bimodal distributions. And then if I look back at this first one, compared to the others, this compared to the others, this is the one that looks most normal. It's not perfect. This one looks like it's skewed a little bit, right? But it's very little data here. It's only one or two. Very little data. This one looks pretty normal. This one looks pretty normal. So I would say that these look the most normal. These look skewed, mostly skewed to the right, and these look bimodal to me. Okay, so hopefully you see it the same way as I do, because that'll make things a lot simpler than if you see them differently than I do. And between me and you, I won't always be the one that's right. Occasionally I do get stuff wrong also. Okay, so at any rate, that'll give you an idea of what you might put in there for words, and I'll publish an answer sheet for that as well. Okay, now the president's histogram. That also caused a little bit of confusion. Let me open that up. Let's see. I updated this one, and I actually tried to give you a little bit of a hint here by putting in the little Abraham Lincolns here. And there's actually two Abraham Lincolns and so many and so forth. I didn't have the time to bother to put in all the presidents, but I was hoping to make that. And I identified the levels. Like, in other words, A represented 40 to 44, and B represented the range 45 to 49. And there were seven presidents, right, or seven Lincolns that were between 45 and 49 years old when they were inaugurated. Okay, so the questions that we had were, which range contains the median age for the president at their inauguration? Well, I tried to be a good guy and I looked up we did this before an old chart that was created before Obama was elected, and so that there were fewer presidents, there were 43 presidents, individual presidents, and so there were an odd number. So now there's an even number. And that caused a problem that I hadn't anticipated. And so 44 presidents, the median age of the presidents, I have 44 ages. The median age would be the age between let's see, half of that would be 22. The 22nd president would be the middle. Well, actually, not really the middle, because it would be 24 to one side, 22 to one side, 22 to the above. So we'd really average the two ages between the 22nd and the 23rd president for the median, since it's an even number, right? So that would be the 22nd president. We'll see what the 22nd president is. So working up from the bottom, two presidents are young, very young. Then we have seven presidents. That's nine presidents. And then we have 13 presidents. That's 22 presidents. So the bottom 22 are C, B, and A. and the upper 22 are in D, E, and F. So you're stuck. It's really right on the line here, isn't it? So I would accept either answer, C or D, for where the median age of the president is, right? The median age of the president is one of these two bars, or between the two bars. There really isn't a between the two bars, technically, but that's kind of, like that's kind of way you would have to need to look at it. Okay, so what's the 25th percentile? Well, 25th percentile, well, the 50th percentile is the median, and we know that we divided A, B, and C, and D, E, and F. So the 25th percentile is going to be the middle of the lower half, right, which would be the 11th president. Well, this one works out a little bit better. So 2 and 7 is 9, so we haven't reached the 11th president. So the 11th president is in the bar C, right? And the 75th percentile is going to be 11 from the top. So we got 3, we've got 7, and 3 is 10, so the 11th president is going to be in the bar, which is D. Okay, what's the probability a president was collecting Social Security, was age 65, right? Is our conditional probability, right? We have one of those. If given that the president is among those that were inaugurated when they were 50 or older, what's the probability he was collecting Social Security? Well, in other words, that he was over 65. Okay, I use the old age for Social Security, and I want to get nuts, right? So we know how many presidents were over 50. Well, let's see. Over 50, we have 7. 7 and 2 is 9. So 9 out of 44 is going to leave 35 presidents. There 35 presidents that were inaugurated over 50. Out of those 35, only 3 were above 65 years old. So that would be 3 out of 35, or I think that was about 11% or something like that it came out to. So that's what we were looking for there, basically. Okay, so you might get a chart like that. Hopefully, it'll work out a little bit easier. You won't have that issue of the median kind of splitting the two bars and stuff like that. Okay. Question 7, using data provided to discuss test scores, calculate the mean, median, mode, variance, standard deviation, maximum, minimum, maximum, just about everything is basically what I asked for, right? Using Excel. Now, I don't have SPSS on my computer right now. But basically, if we are looking for descriptive statistics in SPSS, what we would do is that we would identify the value that we want to, the variable we want to analyze, and we would tell SPSS, go up to Analyze, go from Analyze, go to Descriptive Statistics, and then choose either Descriptive Statistics or choose Explore. Explore is going to give us more information. So if we choose Explore, we then are faced with the choice of telling what variable we want to work with. So then we would move one of the variables, or more if we wanted to, into the, forget default, not the default box, but the dependent box. We would move it into that box. This is dependent at the top, and it would know that's what we want to analyze. In this case, it might be, what are we looking for here? We were looking for the weights of infants in grams. Okay, so that variable would wind up getting moved in there. So we move that into the explore box, move that into the dependence box, and we would go into plots, and we would tell it, well, maybe we want a histogram plot, so we check that off. Maybe we want some other stuff. It's automatically going to make a box plot, so I don't have to worry about that. Now, in statistics, we want to make sure it's going to analyze all the statistics that we're interested in. It may automatically default to analyzing the statistics in Explore. In descriptive statistics, it doesn't. You have to go in there and kind of check off what you want. Okay, but that's why I usually like to pick Explore, because it gives you so much more automatically. So then we say OK, and we would get our descriptive statistics. We get our box plot, and so on and so forth. I'm hoping that I can get to a picture of a box plot at some point here. So at any rate, that's how we would work that. Now, as far as Excel is concerned, I'm going to open up this value in Excel, this table in Excel, if I can find it. Actually, it's going to be easier to get it here. Okay, let's see. Student test scores. And here are our student test scores. Okay, so what am I going to do with these student test scores? Well, I'm going to try and analyze all these different variables. I want to get them all in the window here at the same time, so I'm going to make this a little bit smaller. Okay. Okay, so I'm going to say my mean. Whoops. Median. Mode. Standard deviation. Whoop, how about variance? Standard deviation. 25th percentile. 75th percentile. Interquartile range. Have I forgotten anything? Range would be the minimum and maximum. Range, minimum, maximum. Okay, so let's calculate. Equals. And we have a function for, oh, we don't have a function for mean, do we? We have a function average. Same deal. And I'm going to highlight all these guys. And there's our mean. And our median, we do have a function for median. Okay, and mode. Okay, what's the mode? Mode is the most frequent value. So we have a frequent value. I'm looking at a couple of 81s and 83s, up to 79s. 79, 79, I guess there must be another one here somewhere. I guess that comes up the most frequently. Actually, there could be more than one. Yeah, if there's more than one, I think it just gives you the lowest value. Okay, variance. We calculated the variance by the hard way previously. I think that's VAR. You notice that like if I keep typing, all the options go away. That's because VAR was enough. VAR, and let's see, highlight these guys. So there's a range that I want to find the variance of. There's our variance. Now standard deviation is just the square root of the variance. So I could do this two ways. Equals square root. Okay, helps to remember the format of the functions. Or I could actually calculate the standard deviation. Standard deviation. Oops, got my equal sign. Parentheses. And it should come out to the same thing. And in fact, it does come out to the same thing. Miracle. Okay, and percentiles equals the 25th percentile is equal to percentile. Okay, and there's a number of different options on percentile. You can just use percentile. Percentile, now it wants the range. See down there, array and K. It wants the range, that's the array, comma, and the value for the percentile. It's going to be 0.25, 25th percentile. Okay, and the 75th percentile is going to be the same deal. Percentile. Okay, and I'm going to give the array, comma, 0.75. Okay, and the interquartile range is going to be the difference between these two. That minus that. And the minimum is going to be, we have a function for minimum. Okay, minimum. And we have a function for max. Okay. And see how quickly you can go through this stuff? Once you get comfortable with SPSS and Excel, this stuff will just fly for you. And that's really the thing that you need. You need some practice working with this stuff. Okay, so we're at about 1 o'clock. I think we put in an hour on this. I think that's a pretty good start. Unfortunately, I don't have a working version of SPSS on my computer right now. The license ran out on it, as I mentioned here before, and I have to get it updated. It hasn't been the easiest thing for me to do so far. I think we're in pretty good shape there. Now we're going to learn some new stuff on Monday. We're going to start talking about normal distributions. So homework 2B, I've suggested that you wait until after class to broach that because that's going to introduce a lot of new material. So if you're adventurous and you want to go and take a look at it, you can try it. You can try and do it, and you might be pretty successful at it. Who knows? But in any case, you could always resubmit if you. So there's no reason you won't be punished for giving it a try. and not doing that well. So you always have a chance to resubmit it before the exam. Okay, so I made those both due the night of the exam, but really you want to get them done earlier so that you know where your problem areas are, because that'll help you identify them. Okay, so I'll see you tomorrow night. Okay, have a good day, and perhaps some of you are going to be watching the Jet game like I am later on. So hopefully they'll beat the Eagles today, go 3-0. Who knows? That'd be a that'd be a real miracle. Almost as big a miracle as Pope coming to New York. Take care, guys. Have a good day.